Hello friends, I am Kushag Gupta from VIT Chennai and I am going to present you on the topic application of context-free grammar in speech recognition. Content. We will talk about the introduction, theory computation, speech recognition, context-free grammar in speech recognition and then summary. Introduction. In this presentation, we will going to see how the context-free grammars are being used and what is the real meaning of the context-free grammars and the four major applications like in the meeting and in the Alexa we will use will be entirely covered. Let's start. First, context-free grammars. Context-free grammar is a specific kind of formal system which defines the structure of valid string in a particular language. CFG is a type of formal grammar that is used in computer science to describe the syntax of the language. It is based on the following certain following components. The components of context-free grammar are V. It is a set of non-terminal symbol or variables. These are the symbols which can be replaced. These symbols are represented by the capital letters, which it can be replaced by a terminal or a non-terminal based on the given production rules. T. A set of terminal symbols. These are the symbols which cannot be replaced and are typically denoted by the lowercase letters. A set of production rule. These rules define how the variable can be replaced by the combination of terminals and non-terminals. As the start symbol. This is a symbol from which the production began. A production rule in the CFG is of the form V gives W, where V is a non-terminal and W is a string containing of terminals and non-terminal. The key characteristic of CFG is that the left hand side of the production rule consists of only the uh, single non-terminal symbols. Now we switch to the speech recognition. Speech recognition. Speech recognition is an interdisciplinary subfield of computer science that develops methodologies and technologies that enable the recognition and translation of spoken language into text by computers. It is also known as automation speech recognition, computer speech recognition, or speech to text. It incorporates knowledge and research in the field computer science, linguistics, and computer engineering fields. The reverse process is speech synthesis. Some speech recognition systems require training, wherein individual speakers read text or isolated vocabulary into the system. The system analyzes the person's specific voice and uses it to fine-tune the recognition of that person's speech, resulting in increased accuracy. Systems that do not use the training are called speaker-independent systems. Speakers systems that use training are called system independent. Now we talk about the algorithms that are behind the speech recognition. Algorithm that work for behind speech recognition is first it is audio input. The process begins with the speaker speaking into the microphone. The speaker recognition system captures this audio input for processing. Then it start with phenomena identification. The system then analyzes the speech patterns to identify phenomena, which are the basic unit of sound in the language. When we speak, our voice generates little sound packet called phones, which correspond to the sound of letters or group of letters in the words. Word formation. The identified phenomena are then grouped together to form a words. Contextual understanding. The system uses natural language processing to understand the context and meaning of the word formed. This involves understanding the grammar, syntax, the structure of the language. Conversion of to text. Finally, the understood speech is converted into written or machine readable text. And then we move toward the picture. This picture shows uh, how the speech recognition work. We will understand it through image. About this picture, what is the real meaning of this picture? We will understand that. Audio input. The process begins with user speaking into microphone. The speech recognition system captures the audio input for processing. Then phenomena identification. The system then analyzes the speech patterns to identify phenomena. When we speak, our voice generate little sound packet called phones, which correspond to the sound or letters or group of letter in words. Then it converts into the text. Finally, he understood the speech is converted into written or machine readable text. Before that, there are various processes like it generate the phones. If the word are grouped together to form the words, and the system uses natural language processing to understand the context and the meaning. This involves understanding of grammar, syntax, and structure of the language. Now, we will talk about our main component, that is how we can use the context-free grammar in speech recognition. Before that, we will understand the theory behind it. CFGs are particularly useful in speech recognition system. These system convert spoken language into written text, and CFGs help to structure this process. They provide a set of rules that can be used to parse spoken language, helping the system to understand the structure of sentences and to identify where words begin and end. Then some of the main applications of context predominant speech recognitions are: one of the main application of CFG is speech recognition is in natural language processing, that we short form is NLP. NLP is a field of AI that focuses on the interaction between computers and humans through natural language. The ultimate objective of NLP is read, decipher, understand and make sense of human language in a valuable way. CFGs are used in NLP to parse sentences and check for grammatical correctness. They can also be used to generate sentences that are grammatically correct. This is particularly useful in applications such as automated chatbots and voice assistants where the system need to generate human-like responses. Another application of CFG is speech recognition is in language modeling. Language models are used in speech recognition to predict the probability of the given sequence of words occurring. CFGs can be used to structure these models, providing a set of rules that a model can follow to generate or recognize valid sentences. Then in automation, automatic speech recognition ASR systems are used, where CFGs are reduced to the search space of possible transcription and by constraining the combination of words based on the grammar rules. This makes the ASR system more efficient and accurate. In conclusion, to this application, context free plays a crucial role in speech recognition, providing the rules and structure that allow the system to understand and generate human language effectively. These applications in natural language processing, language modeling, and automatic speech recognition are fundamental to the operation of the system. Then we will talk about the semantic analysis. Semantic analysis plays a significant role in speech recognition and natural language processing. While context-free grammar provides a syntactic structure of sentences, semantic applications analysis adds another layer of understanding by interpreting the meaning. First, semantic analysis contributes. Here are some key points. Understanding its context. Semantic analysis helps in understanding the context of words and sentences. It allows the system to differentiate between homonyms. Homonyms means words that are spelled and pronounced the same but have different meaning based on the context in which they are used. Improve accuracy. Accuracy is improved meaning sentences. Semantic analysis can improve the accuracy of speech recognition system. It can also help the system to accurate describe homophones have different meaning and based on the context, enhancing user interaction. In applications like voice assistants and chatbots, semantic analysis enable the system to understand user command or queries better and provide more relevant and accurate responses. Information extraction. Semantic analysis is crucial in extracting meaningful information from text data. It can help identify entities, relationship, and fact in the text, which can be used for further analysis. Let's move to our future. What is the future of CFG in speech recognition? Future of context-free grammar in speech recognition is likely to be influenced by advancement in several areas. Is SLMs. SLM is a novel approach that combines pretend foundation speech and language. It uses an adapter to bridge the gap between speech and textual embeddings. That not only improves the performance on conventional tasks such as ASR and AST. AST means automatic speech translation, but also introduces the capability of zero shot instruction following the more diverse tasks. SLM can perform unseen generation tasks including contextual biasing using real-time context, dialogue generation, speech continuation, and question. Deep learning. Deep learning has shown significant improvement in the field of speech recognition. Neural networks such as convolutional, recurrent, and more recently transform networks have applied to ASR and have achieved great performance. Deep learning algorithms work better at understanding dialect, accents, content, uh, and at last the hybrid approach. The hybrid approach incorporates neural network approach into state-of-the-art continuous recognition system based on hidden Markov to improve their performance. The approach has gained prominence in recent years with performance improvement yielded by deep network. Then we will move toward this picture. The system in the diagram combines the result of these two ASR engines to improve the accuracy of speech and recognition. Here's the breakdown of process depicted in this image. Speech audio input. This process starts with speech audio input which is fed into the system, splitting the audio track. The audio stream is split into two separate streams. A large vocabulary ASR. The one stream is sent to an ASR engine that operates in large vocabulary mode. The engine is designed to recognize a wide range of words and phrases. Then grammar-based ASR. The other stream is sent to an ASR engine that operates in grammar-based mode. This engine is designed to recognize speech that conforms to a specific ASR result. Each ASR engine produces its own result. These results from the large vocabulary ASR may include a list of possible words and phrases along with their corresponding and confidence scores. The result from the grammar-based ASR may include a parse tree that shows how the recognized words fit together according to the grammar. At last, the summary. Many developments have been made utilizing the context-free grammar in speech recognition for past few years, and many experiments are conducted to improve this. And just I have told about the future generation, we will see the advancement in the near future. Here are some pictures of speech recognition. How will advancement will? And thank you for listening me. Thank you.